guys. So yeah, I'm not Sam. So if anybody's expecting Sam, sorry about that. I hope he's not too bad. So yeah, my name's Martin. I'm here from Microsoft. I was here anyway, and Mike asked me to step in and do this talk, which I've done a few times. So don't worry, it's not going to be really bad. Right? Normally, substitute talks are awful, but this one won't be. I promise it'll be useful. So we're going to talk about machine learning for Muggles.
Is your microphone on?
Is my microphone on? Which one? I've got two.
That one.
This one? That one? Is that
Perfect, that's better.
Okay.
Thank you.
So machine learning is really important. It has been for several years. It's whenever you use an app or a website or any kind of digital thing these days, you're probably using machine learning. Every time you do a search on Bing or Google or wherever you do searches, that's full of machine learning. Whenever you buy something, that's machine learning. Whenever you listen to music on Spotify or Sonos or wherever you listen to music, that's machine learning. So pretty much every major digital thing has been built using machine learning these days. It's a very important thing to understand, and it's now becoming available for developers to start building and using within their own regular applications. So to start our journey of machine learning, we're going to explore the boffin. There are any boffins in the room today? Anybody that's a data scientist, somebody that's been to university studying machine learning or anything like that? You're just regular developers, hopefully, yeah? Web developers mainly, I guess, yeah? Good. So no boffins in the room. So a boffin, machine learning is a very academic thing. So these guys like these are the ones that build machine learning APIs and machine learning algorithms. And it's generally a very mathematical, scientific thing to actually put machine learning together. And these boffins do some quite scary things. So these words here, these are machine learning algorithms, and they're mathematically, academically proven algorithms. They're not something that a particular company owns or has built. They're just equations that are out there that do things around machine learning. I don't really know what any of these things really are or what they really do, but these boffins do, and they're the ones that build these machine learning algorithms. And this is kind of one of those algorithms in pictorial format. I don't really know which one. It's just I think it's reinforcement learning, but I'm not really sure. But it's a very academic, very scientific kind of thing. It's actually a very scary thing. If you're a regular developer and you just write code, JavaScript or whatever language you write, machine learning is quite a scary thing to kind of get your head around and get into. But what I'm here to tell you is machine learning is for Muggles too. So because nobody here is a boffin, you therefore must be Muggles. So you don't possess the magic that boffins have, the magic of data science and understanding the maths and science that sits behind machine learning. So this talk is for you. This talk is going to help you understand how to tap into machine learning and use it within your everyday applications. So let's start by exploring what is machine learning. It's a term that I'm sure everyone's heard, but not everybody really fully understands what it's all about. It's actually very, very simple. Machine learning finds patterns in data. So if you've got a data set, it doesn't have to necessarily be a big data set, just a set of data. Machine learning finds patterns in that data, and then it provides insights in new data using those same patterns. So if you've got a data set of, say you're in e-commerce and you've got a load of order history, that's a data set. A machine learning algorithm will be able to find patterns that indicate why customers buy certain things and when they buy things together. And then when you've got a new customer, you can compare that to the existing data set to find patterns and expose insights in that new data. So conceptually, it's quite simple. There's lots of scenarios where machine learning is used today. So credit card fraud is one of the main ones. So if you've got 100,000 credit card transactions and you know which ones were fraudulent, machine learning can find the patterns that indicate fraud so that when you've got a new credit card transaction, you can say, is this likely to be fraudulent or not? And the machine learning will say yes or no, or give you a score out of 100 actually. We've got things like customer churn. So Sky use this. Sky can predict when somebody's about to leave their service because they've got machine learning algorithms that will look at why people left in the past and therefore predict based on the things that you do in your account. Maybe you downgrade some of the services, maybe you stop watching so much, whatever the indicators might be. And they can predict when you're about to leave the service and they can maybe offer you some incentives to stay or do something like that. Recommendations is an obvious one. So Amazon use this all the time. They were kind of the pioneers of this stuff. So customers that bought these two things also bought this thing as well because it goes really well with those other two things. Again, that's machine learning. That's looking at historical data. Why did customers buy those two things? If you've bought a Raspberry Pi and a Raspberry Pi case, you might also be interested in a Raspberry Pi screen to go with it. That's machine learning in action as well. There's lots of scenarios. So natural language processing is another really key one. So this is this ability for computers to understand natural human language. So you give it a sentence the way I would speak to any of you guys, just a normal human sentence, and the machine can actually understand what you mean in that sentence and what the key words were in that sentence. So lots of scenarios where machine learning is used, and actually, like I say, if you used any kind of app or website that's of any sort of size, you're probably using this stuff already without even realizing it. In fact, it's any scenario where a pattern can be recognized in data. So if you've got a data set, it doesn't have to be huge, it can be a couple of hundred rows potentially. You can recognize some patterns in that data and expose some insight. So data is really the key thing for machine learning. You can't do machine learning without data. And the more data you've got and the better quality it is, the better your machine learning insights are going to be. So let's just work through a little example here around credit card fraud. So can anybody identify the pattern in this data set? So we've got four transactions with a name and an amount, and the middle two were fraudulent transactions. And there is a pattern that indicates which ones were fraudulent, which ones weren't. And just shout out when you can spot what that is.
Starts with P.
Exactly right. So gentleman in the front row there, the pattern is that if your name begins with P, you must be a fraudster. Okay? That's what this data tells us. It's a very small data set. There's only 8 data points. We've got a name and a transaction across, a name and an amount, sorry, across 4 transactions. And if your name begins with P, you must be fraud, so that's what it tells us. So have we got any Pauls or Peters or Paulines in the audience today? There we go. So this gentleman at the back must be a fraudster based on this data set, so watch out for him at the break. So clearly that's not a very good, it's not a very good model to use. Clearly we can't say if your name begins with P, you're a fraudster. But that is what this data set tells us. There we go. If we've got a bigger data set, again, this is still tiny, but we've got a bit more data, we can start to draw better conclusions and better insights. So there are 4 indicators in this data set that indicate fraud. And can anybody spot what they are? Just shout out if you can spot them. There's Russia. So what is it about Russia particularly? So used in Russia is one of them, yeah. There's another 3 to spot.
20-something?
Yeah, age, yeah, so they're all in their 20s. Another 2? Issued in the USA, yeah, and there's one more indicator.
Over £1,000?
Over £1,000, exactly right. So the 4 indicators are transactions that are over £1,000, issued on a card issued in the USA, used in Russia by somebody in their 20s. Now that starts to feel like a better model for indicating credit card fraud. You could probably take that and say, yeah, that's a decent enough way to indicate. Now this is a tiny, tiny data set. And you can start to see it took a room of probably about 40 people, maybe 30 seconds to figure that out. And we're all quite smart people, developers. A machine can do that instantly across massive data sets, across massive rows and columns of data with much more sort of much more subtle connections than these 4 that we've got here. There probably are other indicators in this data set that we haven't spotted. And that's what machine learning is all about. Our human brain just doesn't work in that way where we can traverse large amounts of data and spot patterns. Machines and computers do that very, very well, and they do it very, very quickly as well. And that's why machine learning is a thing at the moment. So imagine if you had 10 million records and 60 columns, which is more realistic for credit card fraud. So somebody like Amazon will have that volume of data. How can a human ever spot the patterns in that kind of data? But a machine can very, very quickly, and they can iterate on that as well every day potentially if they need to. So that's what machine learning is all about. It's about data and it's about patterns in data. The problem is it still feels a bit like it's for boffins a little bit. So you still need to know about the algorithms to use. You need to know when to use which algorithm, when to use different algorithms. You need to know how to clean your data and prepare it for machine learning. There's still quite a lot of work that's involved. And if you look at any kind of job pages now for IT, data scientist is one of the best paid jobs in the industry. And a data scientist is somebody that can go in, use some data and build a machine learning experiment around that data to provide some insight. And it's a very specialist skill. It's a skill that generally developers don't have, or it doesn't align well with writing code. It's an analytical data-based skill rather than a code writing skill. So it is still a bit for boffins, and certainly if you want to go into machine learning, that's an area you can definitely learn, but it's quite academic and there's quite a lot of theory and principle to learn. And that's why we have something called Microsoft Cognitive Services. So what cognitive services? Oh, by the way, we have machine learning as well. If you want to do machine learning, we've got services on Azure that help you build those experiments. But Microsoft Cognitive Services kind of gets around this leap between being a developer and a data scientist. So it was really about adding some of the smarts of machine learning to your applications without having to understand machine learning and understand the theory and practice of it. We have a set of machine learning based APIs. There's actually 30 APIs, which do things like computer vision and natural language processing and text analytics and stuff like that, that you can just tap into in any app and any platform. They're just generally very simple REST-based APIs, and they're either free or cheap to use as well. So for those of you that are going to be at the Hack this weekend, this is one of the areas that we'll be giving out prizes for people using these APIs in the Hack. There are 30 plus APIs broken into 5 categories. So we've got computer vision, and that's all about a computer understanding a picture, an image of some sort. It's things like object detection in images. I could take a picture of this scene here and it'd say it's a laptop on a lectern with a clicker device. Actually, I think that's a recorder. Sorry, I've messed the sound up there. There's a face API that can understand human faces. It can understand 27 different landmarks in the face, so where the pupil, the left side of the pupil is and the right side of the pupil, where the nose tip is, whether somebody's got a beard, whether they're wearing makeup, whether they're looking directly at the camera or not. There's a ton of stuff around the face API. Emotion, which is all about detecting human emotion in faces. Content moderator, which is all about understanding content and moderating profanities, that kind of thing. Video, there's just a ton of them, and each one of these APIs, each one of these single lines has maybe 5 or 6 different things that it does as well. So you've just got a massive ton of capability around bringing these machine learning smarts into your application. The language ones are all about understanding language and text. So text analytics does things like sentiment analysis, key phrase extraction, topic detection in a piece of text. We've got the translation API, which can translate different languages based on machine learning rather than just simple machine translation. We've got the language understanding service, which is our NLP. So you can give it a human sentence and it will understand the intent and the entities that are being talked about in that sentence. So I can say, what's the weather going to be tomorrow in Birmingham? It will understand that what I'm trying to find out is a weather report. It'll understand that I'm talking about Birmingham, and it'll understand that I'm talking about tomorrow, which is Saturday, the whatever date it is, the 21st of October. And it can understand all of that based on machine learning. We've got speech APIs that can do voice to speech and speech to voice. Sorry, voice to text and text to voice. So when you talk to Siri or Cortana or Google Helm or Alexa or whatever the thing is that you talk to on your device, it's these kind of APIs that it uses. And actually Cortana uses that actual API. So when you talk to Cortana on your PC, if you have a PC, it's the Bing speech API that's actually understanding what you're saying and translating that into text. We've got a custom speech service which has specific acoustic environments that it can account for. We've worked with one of the F1 teams with this so that they can take their radio transmissions from drivers going around the track and filter out all the background noise and understand the specific terms that are used in F1, like box in F1 means come into the pit. It doesn't mean a cardboard box, and it can understand that. It can understand that means pit. We've got a load of search APIs that are built around Bing. You can build your own version of Bing using all of this if you want to. And then we've got a load of knowledge APIs that do things like recommendations, frequently asked questions analysis, linking things together. Decision services is a great one if you're a web developer, because it can change the content of a website based on how people use the website. So if you ever used MSN, that's using this service because it will change what it shows you based on what you click. I'm an Aston Villa fan. I'll click on an article about Aston Villa. It's going to show me more articles about Aston Villa. That's the idea. So a ton of stuff, load of capabilities in there. And I'm just going to show you just a few of these APIs in action. So like I say, there's 30 APIs. There's probably like 300 things you can do with them. I'm going to show you just a handful of some of the more popular ones. So you can go to Cognitive Services just by searching for Microsoft Cognitive Services. This is where you'll end up. It's part of Microsoft Azure. And each API kind of has this little portal that you can use to kind of test it out and understand what's going on. These are all the APIs, and it's always expanding as well, but right now we've got 30 of them. So let's have a look at the computer vision API. This is all about understanding images. So we've got like a little sample application here with an image of somebody swimming, and we've got on the right-hand side, we've got the data that it can tell you about that person swimming. So if we click on, we've got the skyscraper one, it says outdoor, building, city, photo, black and white, skyscraper. It's understood the content of the image. It's also given me information about the categories. It's given me information about the dominant colours in the image. This is just a black and white image, so there's nothing that interesting about the dominant colours, but it's fully analysed the content of the image and it's telling me all about that. This reads text in image, so you can take some text. This reads handwriting, so you can convert handwriting into actual text, like strings that you can use in your application. So if you've got this piece of handwriting there, this is the text that you'll get back. It's all from an API. This does thumbnail generation, so it understands the region of interest in the image, and it will crop an image around that region of interest. So that's just one of the APIs. That's the computer vision API. The next one I want to look at is the emotion API. This understands emotion in human faces. So we've got a stock image here, but this is my daughter Madison with a slightly unusual expression on her face, I think. So I'm going to try and upload this image to the API to see what her expression actually is. So we just upload it. It's going to analyze the image. In a second, it's going to show me which region of the image represents her face. So there we go, it's put that box around the face, so it's giving me the bounds of the image where the face rectangle is. So that's good, she's got a face, she's human, that's excellent. And then it's going to give me across 8 sort of global emotions, what her emotional state is. Now the overriding emotion here at 58% is contempt. And then below that we've got 26% disgust, and then we've got 7% anger. So that's what a 3-year-old looks like if they're contemptuous, disgusted and angry with you. So just in case you're ever wondering there, those of you that are parents. This is an application that does real-time analysis. So it uses the same APIs, but using real-time. So I'm going to start a feed using my webcam. This is just in my son's bedroom at home. I start pointing the thing around, and it's going to give me a description as I'm pointing. So it's saying electronics, indoor computer display, move across there, and it's giving me different descriptions. It's basically taking a photo every second and posting it up to these APIs. That's all my son's mess, cluttered, that's right, it is, messy. And it's just able to do this basically in real time. And I can basically switch the API that I'm using here to do something else in real time. So I can do emotions, and I'll start pointing it at myself here and try and do some emotions. That's me being happy, apparently. That's me being sad. It's weird because I keep having to look at the monitor to see where it's working. So it's neutral. That's surprise, supposed to be surprise. It is just about surprise. We can also do face detection as well. So I can point that at myself, and it's saying that I'm a 29, it's great, I'm 38 years old, so that's good. Facing the camera, I'm a male. So, and these are just some of the things. There's actually a ton of stuff behind this API that you can expose. So that's the real-time feed. The next thing I wanted to show was around, this is a website called Twins or Not. It's actually not available anymore, sadly. It got taken down about 2 weeks ago. But Twins or Not basically uses the face API to detect whether 2 people look the same and whether they're the same person or not. So it uses this API, and this is some of the data that you can get from the face API, so where the pupils are, all that kind of stuff. So I've been told to look a little bit like Jake Gyllenhaal, you know, the very handsome American actor. So we're going to see if this is true. So I'm going to upload a picture of myself to this website. And then we're going to upload a picture of Jake, and it's going to tell us whether we're twins or not. So there's Jake, the handsome devil. 89% match. So we are twins. It must be true. It's data science, machine learning says this is true. It must look like Jake Gyllenhaal, so that's cool. But then there's another one, howold.net, which assesses how old somebody looks. So I'm going to upload a photo here. I was 37 when this photo was taken. It's not a very good photo, and it makes me look 42 years old. So that brings me down a peg or two. 1 minute I look like Jake Gyllenhaal, next minute I'm 42 years old. So let's just check if Jake looks his age. He's the same age as me, and he looks 43, so that's excellent. He looks a year older than I do, so that's cool. Happy with that. Talking about happy, this is a website called howhappy.co.uk, which I built myself. You can upload a photo which features a range of faces. This is a Justin Bieber concert, and it will, it will arrange faces in order of happiness. So we can see this young lady here is the happiest person in the room. She's 94% happy. Weirdly, her friend next to her is the least happiest person at 6%. So that's an interesting little experiment. The next thing we're going to look at is, let's see where this is going. Lewis, yeah. So Lewis is this natural language understanding thing, and this How Happy website uses Lewis behind the scenes. So the way Lewis works is you kind of give it a piece of text. So I'm going to say all on here, and this understands that I want to turn all the lights on in the image, and it's basically doing that. So this How Happy website uses Lewis as well. So you can say things like, who is the happiest one here? So this time I'm looking for the #1 happiest person, which is obviously this young lady here. But it's understood that the intent of the question was slightly different there. I can say, show me all the angry people. So it's going to, this time, do the same search but filtered on anger. So who's the angriest person in the room? It's the dad at the back, of course it is. It's a Justin Bieber concert. But it's understood that I'm talking about anger this time rather than happiness. I'm going to say, who's the third most surprised person here? So this time I'm looking for #3, it's this young lady again, but I'm also looking for surprise rather than happiness or anger. And I can also say, who is the least happiest person here, just to sort of finish it off. Notice that I'm using words like happiest rather than happy. That's because I can't type. And the least happiest one is her friend there. So I don't know what Justin Bieber's doing on stage at that point, but there we go. So that's a combination of using the Face API with the Natural Language Understanding API to do something interesting. The next one that we want to look at is the Recommendations API. This does the kind of typical Amazon-based, so customers that bought this, bought that, frequently bought together, all that kind of stuff. And we have a website here that has a listing of books. It's just some sample data. And with each book, I've trained the API based on these books and the purchase history of these books. And you can click in and you can kind of say, people that have read The Piano Man's Daughter might also be interested in these other books. So it's a very, very simple website. I've got a more up-to-date one, which is a sports website, which if anybody's interested, I can show you that. Based on, we worked with JD Sports on using their data set. So, but it's very easy to train. All you need is an inventory and some purchase data, and it can figure it all out and provide recommendations for you. So that's just kind of a very quick run through just some of the APIs that we have. Like I've really just scratched the surface there. There's a load of other stuff that I haven't shown, but that should hopefully give you an idea of how this stuff works. So there's been some kind of silly demos there. We've looked at, do I look like Jake Gyllenhaal? Is my daughter contemptuous? Yes, she is. A few other things, book directories, but it's not all just silly demos. So this is a video, and hopefully the audio is going to work here, which shows a slightly more serious side of these APIs and what you can do with them.
I'm Saqib Sheikh. I lost my sight when I was 7, and shortly after that I went to a school for the blind. And that's where I was introduced to talking computers, and that really opened up a whole new world of opportunities. I joined Microsoft 10 years ago as a software engineer. I love making things which improve people's lives, and one of the things I've always dreamt of since I was at university was this idea of something that could tell you at any moment what's going on around you.
I think it's a man jumping in the air doing a trick on a skateboard.
I teamed up with like-minded engineers to make an app which lets you know who and what is around you. It's based on top of the Microsoft Intelligence APIs, which makes it so much easier to make this kind of thing. The app runs on smartphones, but also on the Pivot Head smart glasses. When you're talking to a bigger group, sometimes you can talk and there's no response, and you think, is everyone listening really well, or are they half asleep? And you never know.
I see two faces, 40-year-old man with a beard looking surprised, 20-year-old woman looking happy.
The app can describe the general age and gender of the people around me and what their emotions are, which is incredible. One of the things that's most useful about the app is the ability to read out text.
Hello, good afternoon. Here's your menu.
Great, thank you. I can use the app on my phone to take a picture of the menu, and it's going to guide me on how to take that correct photo.
Move camera to the bottom right and away from the document.
And then it'll recognize the text. Read me the headings.
I see appetizers, salads, paninis, pizzas, pastas.
Hi. Years ago, this was science fiction. I never thought it would be something that you could actually do, but artificial intelligence is improving at an ever faster rate, and I'm really excited to see where we can take this. As engineers, we're always standing on the shoulders of giants, building on top of what went before. And in this case, we've taken years of research from Microsoft Research to pull this off.
I think it's a young girl throwing an orange frisbee in the park.
For me, it's about taking that far-off dream and building it one step at a time. I think this is just the beginning.
Okay, so there's quite a lot of amazing things in that video, I think. Firstly, the guy's blind and he can write code. I don't know how that even works. I can't write code and I've got full use of my eyes. So that's amazing in itself. But the other thing, so I know Saqib quite well. He works down in Reading, where Microsoft are based. And that came about as just a little hack that he did with a few colleagues. We have these hack things that we do internally at Microsoft where you can just go and work on something that you want to work on. So Saqib teamed up with a few other guys and built that in just a few days. And the thing that's really cool about that app is that it's really very, very simple. All that happens is those glasses are connected to his phone over Bluetooth. When he does that motion, it takes a photo, basically. Sends a photo to his phone. The app on his phone then sends it up to a few of the cognitive services. We've got the computer vision one, you've got the emotion one, you've got the text analytics one. And the app then takes the data back, figures out a description to give back to Saqib, sends that back up to the glasses, which he hears through a headset. So really, all it's doing is it's taking a photo, passing it to a few APIs, and just trying to make some sense of the results. It's a very, very simple application, which was written in a few days. But the impact on somebody like Saqib and how that helps him understand the world around him is quite huge. So again, just a few of the APIs involved there. There's a bunch of stuff that I think that app is actually now available in the US. It's called the Seeing AI app. So you can download that if you set your phone to US. So there's a few things we've covered there. So we've covered machine learning, the principles of machine learning. It's all about data. You can take any data set, you can apply some machine learning algorithms to it, you can find patterns in that data and then use those patterns to provide insight in new data. We looked at the credit card example where we can see that the bigger the data set, the better the patterns. Although it doesn't have to be big data. A lot of people think machine learning only works if you have millions of records. That's not true. You can do this stuff on just a couple of hundred rows of data if you need to, if that's all you've got. There's a service in Azure called Azure Machine Learning to help you build those machine learning experiments. We then looked at cognitive services, which is this idea of taking machine learning experiments that Microsoft have already built using data we've already got, using data scientists we've already got, and exposing the API for you guys to use in your applications. So there's 30 cognitive services that do a whole load of different things, and we saw some around computer vision, around text analytics, around recommendations, but there's a bunch of others that you can go and explore as well. For those of you that are at the Hack this weekend, Microsoft's obviously sponsoring Hackference, and our prize is a Sonos speaker for each member of the Hack team. And it's around cognitive services as one of the technologies, and the other one is the bot framework, which I'll talk about a little bit tomorrow during the kickoff. But if you want to build an app using some of this stuff and you're at the Hack this weekend, then there's prizes to be won there. I'd love to see somebody build something with the Starling APIs, like a Starling bot or something like that. That'd be really cool. So that's cognitive services. Just a little shout out as well, to go beyond the Hack. Microsoft are looking for companies to work with to build these kind of applications in a real world way. So if you've started something at the Hack this weekend and you work for a company and you think that might go forward into a production application, come and see me, because we're looking for companies to work with. We want case studies, like we worked with JD Sports on the recommendations API. We want to be able to go to events like this and say, we've worked with JD Sports on the recommendations API, and this is what we learned. So if you're kind of excited and interested about this stuff, come and see me and we'll try and work together. So for now, this is me. There I am. You can get me on Twitter, you can get me on email, you can go to that URL where you can find some version of these slides. I'm here all day and I'm going to be here all weekend as well at the Hack. Well, not all weekend, but most of the weekend at the Hack. I think we've got a little bit of time for any questions if anybody's got any. No? Yeah?
We've got about 5 minutes if you guys have any questions. Or we did Martin entertain us for more.
Yeah, I think my entertainment's done for the day, unfortunately. So, okay, well, that's cool. So, like I say, if you want to come and talk to me directly about questions, that's fine. I'll be here. But for now, that's everything. Thank you very much.